right, the final set of observations, we're looking at the cryosphere or ice. So the first type of ice we're going to talk about is sea ice. That's the ice that's just floating on the surface of the ocean. The Arctic Ocean at the North Pole is covered in sea ice during the winter months. And the annual Arctic sea ice extent is decreasing by about 4% per decade. So this image is showing in yellow the average extent from 1980 to 2010, and then in white, the more modern extent. This is from the 2019. So you can see that we're losing more and more Arctic sea ice every year. This graph is showing the exact same thing. You can see that we do see a lot more ice in winter than in summer, which makes sense. But comparatively, year to year, we're getting less in the summer and less in the winter. Right? Now, because the ice is already floating in the ocean, it doesn't actually increase sea level when it melts. Just like when ice in your drink melts, your cup doesn't overflow, right? It's the same volume. So why do we care if sea ice melts, right? Nobody lives up in the Arctic Ocean. Why do we care? Well, the Arctic food chain relies on that stable sea ice platform. And a lot of it starts with sea ice algae. So if you look at the bottom of that sea ice, it's actually really vibrant green, yellow, brown colors because it has algae growing on the base of it. And that's the base of the food chain. So if there's no sea ice there, there's no algae there. If there's no algae there, there's less zooplankton, less food for smaller fish, less food for bigger fish, less food for the seals and the bears and the foxes, and so on, until eventually, right, you get this iconic picture showing polar bears without sea ice to walk on. Well, they also have no food to eat because of this breakdown in the food chain. And I said, people don't live in the Arctic Ocean, but they live around the Arctic Ocean. So this is a quote from one person who does live around the Arctic Ocean. She said, "We don't know when to travel on the sea ice, and our food sources are getting further and further away. Our way of life is being permanently altered. We have no other sources of food. The people in my community are completely dependent on hunting, trapping, and fishing. We have no means of adapting to a different environmental reality, and that is why our situation is so critical." Right? So even places that seem very, very far away and disconnected from humans, they are still very connected to human lives. All right, keeping on sea ice. If it melts, why do we care? Well, it also impacts the temperature of Earth all around the globe, and that's because of the sea ice albedo effect. Sea ice is white, which means it's going to reflect a lot of light back out into space, whereas the ocean is really dark. It's that dark blue, almost black, so it's going to absorb a lot of that solar radiation. We quantify this by albedo. It's the percentage of solar radiation that an object reflects back into space. So if that albedo is very, very high, such as a fresh white snow, then the solar radiation is going back out into space, not staying at Earth. But if there's a lot more absorbed, maybe if that snow melts away and it's just open, dark ocean, then a lot of that solar radiation is going to be absorbed. And this creates a feedback loop, right? So to introduce you, hopefully this is not the first time you're being introduced to feedback loops. Feedback loops can either be positive or negative. Now, positive and negative have nothing to do with an increase or decrease, or a good or a bad, right? The positive and negative just mean, will this feedback loop keep going or will it not, right? A positive feedback loop is one that continues to go and it gets faster and faster and faster and faster. A negative feedback loop is one that slows down until it eventually stops. So thinking about sea ice albedo, is it going to create a positive feedback loop or a negative feedback loop? I'm going to give you some examples of positive feedback and a negative feedback to help you out a little bit. So let's think we have the first factor is I'm thirsty, right? And I could go into two feedback loops. I could either go into a positive feedback loop where I'm thirsty, so I drink beer. And when I drink beer, I become dehydrated. And when I become dehydrated and a little inebriated, I'm going to get even more thirsty, so I'm going to drink more beer. And I'm going to get even more dehydrated, more inebriated, and more thirsty, so I'm going to drink more beer. And notice I have gotten into a positive feedback loop where I just get faster and faster and drunker, but I'm still very thirsty. Okay? Now, the negative feedback loop is the opposite. Let's say I'm thirsty and I drink water. Well, now I'm hydrated, I'm sober, and I'm no longer thirsty. So it stops, right? That's that negative feedback loop. So coming back to sea ice albedo, positive or negative? Right? Let's think about it. So if the world is warming, sea ice is going to melt. And if sea ice melts, we have that white material being replaced by dark ocean, which is going to absorb more solar radiation, which is going to cause albedo to decrease. When albedo decreases and more solar radiation is absorbed, the Earth warms. So more sea ice melts. And we get into this positive feedback loop where, because of the sea ice melting, Earth is warming faster and faster and faster.